the science guy. Okay, so on the book problems, I'm going to start with 183 and 185 because I did not get to those second period. So I want to make sure I have those recorded. And if there's anything we don't get to this period, they'll be recorded from second period. Okay? So let's start with number 183. 183. Did I tell you guys I was going to Ramsars last night?
Yeah.
I'm going again tonight.
Again.
I was wearing Birkenstocks, so it wasn't the best climbing shoes.
Excuses.
Well, that was my fault. And I thought about doing it, because what am I supposed to say from the top? Something about AP Chem? Yes. I could have done it, but I didn't want to break my Birks. Because they're like kind of expensive. So, anyways. All right, here we go. Let's do a little bit of Stoic here. We are at 183. I'm really excited for next week. Next week, we're going to actually get into stuff you've never seen before. So we're going to get into net ionic equations. It's kind of fun. It's kind of fun. Net ionic equations, something you've never seen before. Yes. Shapes. We're still a few chapters from that. No colors. So we're going to get into that. And then I think next Friday will be our lab prep day for one of the most iconic labs in AP Chem, I think. And then it's our mixture lab. And then the week after that, we'll be in lab every day. So the good news is there's also another lab after that. So our next test will be like weeks after this. Yes?
When do we go over orbitals?
Orbitals, that's also shapes. Well, no, orbitals would be a little different than shapes. We will, though. You're talking about like 1s2, 2s2, that kind of stuff? Yeah. Did you do that?
Yes.
Yeah, we
Kind
did
of.
that last year.
Okay.
And I took the D4 orbital and like took one S orbital because you make it more stable by going to D5, and Mr. Runk brought it over to you to make sure I was doing.
Yeah.
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 that was tough.
Yeah. Okay. It's all good. 183.
Fred didn't share that.
You may want to have your book open so you can follow along. 183. An element X forms a dichloride. So I'm going to try to highlight in each one of these problems the part where I think that where you might have got stuck. XCl2. So on 183, I have XCl2 and a tetrachloride, XCl4. Treatment of 10 grams of XCl2 with excess chlorine forms 12.55 grams of XCl4. Calculate the atomic mass of X and identity X. Did you write a balanced equation?
Yes.
Okay, good. So my balanced equation I wrote was XCl2. I have XCl2 plus Cl2 yields XCl4. And that is balanced. Agreed? Yes. And on the problem, they told me that I have 10 grams of this. So I have 10.00 grams of this. This is excess. They told me that. And I had 12.55 grams of that. So I'm trying to identify what is element X. See? So here's what I would do. I would take my 12.55 grams of this. So I take my 12.55 grams of that. And I'm going to subtract I subtracted the 10 grams to the 10.00 grams. I should write what I'm doing. This is XCl4. I'm going to subtract my 10 grams of XCl2. Why am I able to do this? What is this going to give me? This is going to give me the mass of my Cl2, right? Because of the law of conservation of matter. Yes? This plus this needs to equal that. Agreed?
Yeah.
Yes? So that's going to give me my 2.55 grams of my Cl. My Cl2. Okay, then I'm also going to take my 10.00 grams of my XCl2, and now, because this is a 1-to-1 ratio, agreed? I can subtract my 2.55 grams of Cl2, because this should be the same mass in both of those, Agreed? Because it's a 1-to-1 ratio. So that gives me 7.45 grams of X. Any questions so far on what I just did? Is that a question? Okay. So now I'm going to take my 2.55 grams, of Cl, because now I'm not doing Cl2 now, because I'm not talking about the molecule, now I'm talking about the element. Okay, I'm talking about the element. And there we know that there is 35.453 grams of Cl in 1 mole of Cl. And how many moles of Cl do I have in XCl2? 2. So there's 2 moles of Cl, for every 1 mole of XCl2. And I know that for every 1 mole of XCl2, I have 1 mole of X. So this is kind of like a stoich step. It's a stoich step within a compound. So I start with something I know. I always start with something that I know. And I knew that I had 2.55 grams of chlorine. So this gives me 0.0360 moles of X. And now I have a gram per mole. So I'm going to take my 7.45 grams divided by 0.0360 moles. And that in my calculator gave me 207 grams per mole, which is what element? Lead. That is lead. So that was 183. Questions on that one? 185. 185 is a little bit similar but kind of different. 185, when aluminum metal is heated with an element from group 6A, that's important, from group 6A. Because group 6A is where on the periodic table? Group 16, right? An ionic compound forms. When the experiment is performed with an unknown 6A element, the product is 18.56% Al by mass. What's the formula of the compound? So, on 185, the first thing I did is I wrote the formula of the compound, which would be Al2X3. Does that make sense? Because we know that aluminum is what charge? Nope. It's always a 3+, right? And X is going to have a 2- because it's from 6A. Yes? Crisscross, and that is the formula of the compound. We good with that? Okay. And I know in this compound, from what they told me, that this thing is going to be 81.44% X if I subtract, right? Because they told me how much aluminum it was. Okay. So, and this is also what percent? What was it? 18.56%? Yeah. Percent aluminum. What am I going to assume? Assume 100 grams. All right, assume 100 grams. So I'm going to turn this into grams. So 18.56 grams of aluminum. And then we're going to go to moles. So 26.981 grams of aluminum in 1 mole of aluminum. And then just stoich your subscripts. For every 2 moles of Al, there is 3 moles of X. So that will give me my moles of X, which I got 1.032 moles of X. I've got grams of X, right? So I'm going to take my 81.44 grams of X divided by the 1.032 moles of X, and I got 78.91 grams per mole, which is what element? Selenium. Se. Did you get the right answer? That would work. There's longer ways to do it. I think this is the shortest way, but you can do that other ways. That was 183, 185. Emily, you good with that? Let's go back to the beginning. Now the lowest number you guys need.
I needed help on 94.
Anything before 94?
I could not for the life of me get it balanced.
Okay. Anything before 94? Okay. 94. I'm going to have to flip the page. Here's the thing on 94. You don't have to balance it. There's nothing to balance. On 94, you have your, oh, I call these a Chani boy. A Chani boy. Carbon, hydrogen, oxygen, nitrogen. Like, not Johnny, but Chani.
That feels.
Oh, Chani boy. Feels what?
That feels like it's like a bad word.
A Chani boy?
Shoddy boy.
Yeah, because it's like a whole page of work to do one of these. Anyways, a compound contains only carbon, hydrogen, and nitrogen. Combustion of 35 milligrams of the compound produces 33.5 milligrams CO2, 41.1 milligrams of H2O. So let's start out with our CO2. I want to see if you guys like this. Usually people don't like how I do this. Second period was disgusted by this. Here we go. 94, I'm starting out with 33.5 milligrams of CO2. Are you guys starting to memorize any of these molar masses?
Yeah.
44.009 milligrams of CO2 in 1 millimole of CO2. Yay? Nay?
Pretty funny.
That's wrong.
Tyler's like, that's disgusting. How do we feel about that? Millimoles. 1 millimole of CO2 would have 1 millimole of carbon. Yes. And 1 millimole of carbon would have 12.011 milligrams of carbon. And there's a reason I'm leaving in milli, because I'm going to divide by a total, and my total's in milligrams.
Yeah.
So why even convert back? You can, you'll get the same answer. So I got 9.14, is that what you guys got?
Yeah.
Milligrams of carbon there.
There's a different way.
There's other ways to do it. Like I said, there's other ways to do it. There's usually 2 or 3 ways you can do one of these problems. Do the same for your water. I had 41.1 milligrams of H2O. There's 18.015 milligrams of H2O for every 1 millimole of H2O. And 1 millimole of H2O, here's where people fault turn and make their mistakes. How many millimoles of hydrogen are in 1 millimole of water? 2. Don't miss this step, because there's a subscript 2. There's 2 millimoles of H, and 1 millimole of H is 1.008 milligrams of H. I got 4.60 milligrams of H. Now, I have to divide those by the total. The total they gave me was 35, right? So divided by 35 milligrams, divided by 35 milligrams, times 100 to get your percent. I'm getting a percent. So for carbon, I got 26.1%. Ooh, that's really bad. 26.1%. For hydrogen, I got 13.1%. How am I going to figure out my oxygen from these two numbers? Subtract from 100, right? Add them up and subtract from 100. And when I do that, for oxygen, I ended up getting, I don't know. Oh, it's not oxygen, it's nitrogen, right? Yeah. It's nitrogen. I got 60.8. Is that something close to what you guys had? Okay, that's fine. 60.8% nitrogen. You're good. Now, what are we going to do? Assume 100 grams. Because all of these percents should add up to 100. So, what? Why do I do percents? Because that's the only way I can get. That's the only way I can get to grams.
So I subtracted the masses.
Subtracted from what?
Like the original mass they gave us was 33.
So you subtracted this mass from 33?
I think so. No, the 35.
You subtracted this from 35. Did you subtract this from 35?
Yeah.
And then you figured out how much mass of oxygen you had?
The nitrogen, yeah.
That would work. Either way. So you're going to take, the way I did it, I did percents. So I got 26.1 grams of carbon, 26.1 grams of carbon, times 12.011 grams of carbon in 1 mole of carbon. I have 13.1 grams of H times 1.008 grams of H in 1 mole of H. And I have 60.8 grams of nitrogen. So 60.8 grams of N times 14.007 grams of N in 1 mole of N. Solve for your moles. And I got 2.17 moles of carbon. I got 12.99 moles of H. And I got 4.34 moles of N. Now what do I need to do? Divide by the smallest. Divide by 2.17, divide by 2.17, divide by 2.17. That's 1 carbon, that is 6 H's, and that is 2 N's. So my empirical formula is CH6N2. CH6N2. So when you have one like that, you run your compound to the individual element and then divide it by the total to get your percent comp. Garrett, you good with that?
Yeah, it makes sense to run it to the individual compounds.
Okay, cool. Next question. Next one you guys want? 117. Anything before 117? 117. I love this question. This is fun. We are talking about bacterial, what is it? On 117? Yeah, bacterial waste, and we're trying to get it to bacterial tissue, right? So on 117, I started out with my bacterial waste. So I'm going to start out with my 1.0 times 10 to the 4th kilograms of waste. First thing I'm going to do, this is the tricky part. All right, this next step is the tricky step where we have to kind of do some thinking on how to put this in your stoic. I'm going to say for every 100 kilograms of waste, what? What are you going to say? Not yet. Not yet. Because we're talking about NH4 right now. For every 100 kilograms of waste, I get 3.0 kilograms of NH4 plus. This is the part that was tricky on this problem. Does it make sense? Looking at the problem, where I came up with this. How did I come up with that? It's 3%, right? It said that it is 3% ammonia. So I assumed 100 grams, and I just said it is to 3. So that was the tricky part. It said that it's 3% ammonia. So I said for every 100 kilograms of waste, I get 3 kilograms of ammonia. Head nod if you're okay with that. I gotta know you're okay with that. Okay, cool. Now I'm ready to do basically stoic from this point on. I know for every 1 kilogram of NH4, I'm going to have 1,000 grams of NH4. Now I'm ready to go to moles. Oh, this is NH4 plus. I should write that. NH4 is 18.04 grams of NH4 plus in 1 mole of NH4 plus. Does the charge affect my mass? No. The charge just means it's an ion. The one that's going to affect mass would be if my neutrons changed, which they didn't. Now I'm ready to stoic step it. In the problem, the balanced equation they gave me, they said that there's 55 moles of NH4 plus for every 1 mole of bacterial tissue. Also known as C5H7O2, but I'm running out of room. And every 1 mole of BT, the molar mass of that is 113.12 grams of BT. So on this one, this was the tricky part, all right? Figuring out what to do with that 3%. So whenever I see a percent, it's usually going to be a rate. You're going to turn it to in the stoic. So you solve for this, and I got 3.4 times 10 to the fourth grams of BT, bacterial tissue. But I'm not done, right? Because on 117, they said, assume that 95% of the ammonium ions are consumed by the bacteria. So now I have to multiply this by what?
5%. 0.19.
By 0.95, right?
Yeah.
Because it says 95% are consumed. So I'm going to multiply this by 0.95, and my final answer was 3.2 times 10 to the fourth grams of bacterial tissue. Could I have also started here and multiplied it here by 0.95? Sure. It doesn't matter where you do it, but you got to do it somewhere to get that down to 95% of what you need. So that was 117. The 3%, this was the tricky step on 117. Next one. 120. That's the next one. 120. Oh, yeah. All right. I have to turn my paper sideways to do this. So I'm going to turn my paper sideways because it's really long. I cannot fit this line of Stoic on the way I write. Are you ready for this? Here we go. On 120, we're talking about astronauts. I love this problem because I watch a lot of sci-fi shows. It's a show like where they're like living in this like tube. It's like a space shuttle type thing. I don't know if it's called like Another World. I can't think of it, but the main character, she's a girl. She's super famous. I don't know. That was a horrible story. All right, let's just do it. 120.
It's not even a story.
No, wait, I know why. I remember why. I'm going to bring it back. What should be the first thing you do on 120?
Watch the TV show.
Watch the TV show and then write a balanced equation. Write a balanced equation. So on 120, I know that LiOH plus carbon dioxide yields Li2CO3 plus H2O. Is that balanced? No. So let's put a 2 here. That's balanced. Here's why I thought of the show. All right? Because in the show, something's going wrong with the carbon dioxide. The carbon dioxide is increasing on the ship. And then someone super smart is like, oh, we have lithium hydroxide pellets for like cleaning something. I think for the water softener. So they take a bunch of lithium hydroxide, they pour it into the ventilation system, and then it causes it to rain on the ship. Because look at what your product is. Water. So like they're all like, oh, it's raining because they haven't been to Earth in like forever. So it was like a really big moment. Number one, because they could breathe. Number two, because it was raining. So, yeah, breathing and rain. Yes. I mean, water and breathing is pretty important. So, we start out with, on this one, 25,000 grams of LiOH. So I have 25,000 grams of LiOH. Okay. Molar mass. 23.95 grams of LiOH in 1 mole of LiOH. Stoic step. For every 2 moles of LiOH, I have 1 mole of CO2. Oh, there's one other thing I would have done before I started this. How many astronauts are on the ship? I have 7 astronauts. And how much oxygen do they need? From the problem. They need 20 liters, right? So that ends up being 140 liters of air per minute. So that's going to be a rate I'm going to need later in the problem. I forgot about that. But I would do that before. 140 liters of air per minute. Because that's going to be a rate. Yes?
Why is it the CO2?
Why what?
The storage step.
Because I have a percent of CO2. There's a rate I'm going to use. I'm going to use that 4% CO2 as a Stoic step later. So I have, you see it? So I have to get it to CO2 in order to get it to air. And then I'm going to use another rate, the density of air, to get it to volume. So you have to kind of think Where are you trying? This is where the problem solving comes in. Think, what do I have to get this to?
Yeah, I skipped straight to the.
Oh, okay. So you're going to have a little smaller number probably. Okay. So I know that 1 mole of CO2 is to 44.009 grams of CO2. And here's the first tricky step. In the problem, on number 120, they said it is 4% by mass for CO2. So that means I'm getting 4 grams of CO2 for every 100 grams of air. That's the first tricky step. Does that make sense, though, what I did? Yes? I'm getting 4 grams of CO2 out of every 100 grams of air? Are you okay with that? Reese, you good? Okay. And now they also gave me the density of air. That's going to be my next step, rate number 1. And I know that air for every 0.0010 grams of air, I get 1 milliliter of air. And I know that there's 1,000 milliliters of air in 1 liter of air. So here's my first rate from the problem. And then here comes the rate we made right here. I know that I need 140 liters of air every 1 minute. So there's the second rate. And then it didn't say what to solve it to, but I put mine in hours because I feel like minutes aren't super helpful. So there's 60 minutes in 1 hour. You guys could have done whatever you wanted to. And then I got 68 hours. 68 hours. So I actually really like this problem because it's kind of fun. It's a really long line of stoic. If you would look probably how the book worked it out, they'll do this in like 2 or 3 steps. I don't know why. All right? If you can make it all one line, make it all one line. Did you get it, Danny?
Yeah, I'm just
Did you get the same answer?
not really close. I got 74.
74. Okay.
But, you know, sorry.
Okay.
I got 70, but
70? That sounds just like SIGDIG rounding. 74 seems a little off.
yeah.
Brock, what are you thinking?
I went to Li2CO3 for some reason.
Oh.
I have no idea.
Yeah, that's not what we're going for.
What are we going?
What were we going for? We were trying to figure out how much time could they survive?
Oh.
How much longer could they breathe based on this many pellets? What?
That's not really that many hours.
That's like 2 days something?
You get, like,
2.7 days something?
Time to survive, like.
It's not there, like, I only got
I mean,
for 9 hours.
let's just hope that they're not very far from home.
Like 2.5.
Are we calculating this because there's going to be
Actually, like 2.75.
Yeah, so on 120, this is talking about the Space Shuttle Environmental Control System. So this is saying how it works. So if there were 7 astronauts on board the shuttle and each exhales 20 liters of air, how long could clean air be generated if I had this many pellets? So I was solving for if I had that much LaOH, how long can I live? That's why. That's what we're doing on 120.
before we run out of air.
Yes. Before we run out of air. That's why I had to figure out that they're breathing 140 liters of air per minute, which seems like a lot. Wouldn't a swimmer breathe less? Swimmer should breathe less than that.
Wait, how many is it?
140 liters per air, so that's 20 liters of air a minute. I wonder what's the size of our lungs?
How much is that like?
Hey Siri, what's the volume of a human lung in liters?
Here's what I found from NIH.gov. Among healthy adults, the average lung capacity is about 6 liters.
So 6 liters, and this is saying that you're breathing 20 liters a minute.
Does the air?
Oh dang, that seems really good now. These people are super healthy.
I mean, also, wouldn't the air be expanded or something, which means you're breathing?
Well, these people are like.
Well, in
People
space,
have to be, like,
you're in a pressurized cabin, so it wouldn't be. Next question. We can't get too far off track. Next one.
People's
I
heart
only
rate
count
has to
them
be,
moving for 9
Tyler,
hours, so I did something.
people's heart rates have to be like negative.
Does it make sense what I did here?
Yes.
That's what I got to know. Parker? Okay.
That's like 3 breaths a minute.
Danny?
What is the LIOH average breath per minute?
What is the LIOH what?
Like
The LIOH, and then we're just figuring how much we're running out
It's
of
8 to 12 breaths.
The LIOH is solid.
I know. So what's math ain't math.
It's those solid pellets are reacting with the carbon dioxide gas.
To not CO2.
That
That
little
doesn't
layer.
asphyxiate.
Right.
Yeah. Just ration the college.
People are like actually like athletic.
Okay.
Athletically gifted.
Next one after 120. 140 what? 148. 148. This one is a Chani boy. This one is a Chani boy. Might as well keep working. I'm already sideways, so let's not waste paper. 148. I have terephthalic acid. It contains only carbon, hydrogen, and oxygen. Combustion 19.81 milligrams, produces 41.98 milligrams. It's 6.45 milligrams. 0.250 moles. Terephthalic acid is 41.5 grams mass. Determine the MF of terephthalic acid. I just love saying MF because it's a molecular formula. Yeah. Ha. I got a couple smiles. Okay. I'll take it. On this one, I'm going to start out once again with my 41.98 milligrams of CO2. Figure out your grams of C. So there is 44.009 milligrams of CO2 in 1 millimole of CO2. Are you guys more okay with millimoles? Are you guys okay with that? Some people are not okay with that.
As long as I get the right.
It makes sense, but it's so weird.
It's awkward.
1 millimole of CO2. What is a millimole? It's 1/1000th of a mole.
How much does one
Is 1 millimole of carbon. And I know that 1 millimole of carbon is 12.011 milligrams of carbon. So that gives me 11.46 milligrams of carbon. Now do the same thing with your hydrogen. So I have 6.45 milligrams of H2O. Does it make sense why we can't do this for oxygen?
Yeah.
Why can't we?
It's in both.
It's in both, right? So I can only do this for the element that's only in one of the compounds. I can only do it for the element that's in one of the compounds. So there's 18.015 milligrams of H2O in 1 millimole of H2O. And in every 1 millimole of H2O, there are 2 millimoles of H. In every 1 millimole of H, there is 1.008 milligrams of H. 1.008 milligrams of H. So I got from that, I can't read my writing, I think I got 0.722 milligrams of H. Divide by the total. So my total was 19.81 times 100 divided by 19.81 times 100, and that will give me 2%. For carbon, I got 57.85% carbon. For hydrogen, I got 3.64% hydrogen. If you take 100 and subtract those, I got 38.51% oxygen. You didn't tell me that was off the screen. So there are my percents. Once I have my percents, assume 100 grams. So 50, am I on the screen? No. Still not. There we go, right there. So I've got 57.85 grams of carbon times 12.011 grams of carbon in 1 mole of carbon. I have 3.64 grams of hydrogen times 1.008 grams of hydrogen in 1 mole of hydrogen. And I have 38.51 grams of O times 15.999 grams of O for every 1 mole of O. So that gives me 4.817 moles of carbon, 3.61 moles of H, and I got 2.4. Why did I go to 3 there? I don't know. 2.407 moles of O. Divide by the smallest. Divide by 2.407. Divide by 2.407. Divide by 2.407. This equals 2. This equals 1. This equals 1.5. Oh, shoot. What am I going to have to do? Multiply by 2. Times 2, times 2, times 2. So I have C with 4, I have H with 3, and I have O with 2. So my empirical formula is C4H3O2. C4H3O2. We good so far? Come up with the rough molar mass of that. 4 times 12 is 48. 48 plus 3 is 51. And then 51 plus 32 is, so this is approximately 83 grams. They told me in the problem on 50, what number is this? 148, that the 0.250 moles, 0.250 moles is equal to 41.5, that's not 41.5, 41.5 grams. But here, this is for every 1 mole. So what do I have to do with this number? Multiply by 4. So times 4 times 4. So for every 1 mole, I've got 166 grams. 83 times what will give me 166? Times 2. Times 2. So my MF is C8H6O4. Yes.
I understand all the way up to the empirical formula, but I'm confused on that molecular formula part, like the 0.2.
So in the problem, they said that 0.250 moles of terephthalic acid weighs 41.5 grams, right? But we can't go to a quarter mole. So times 4 times 4. So every 1 mole is 166 grams. So that was just a little conversion they just threw in there, just to make it an extra step. We never did anything like that in CP Chem last year because it's kind of silly. So that was that. I could probably do one more before the bell rings.
Are we gonna have one like this on the test?
Like this? Not where I'll do this. I would expect you to be able to do this up here, but not this. That's just an extra step for silliness reasons. So, how much time do we have left? I could probably do one more. What number? 150. Okay, let's do it. Oh, this is a fun one because it's my initials. That's why I picked this one. It's also Emily's initials.
It is.
150. 150, they tell me that I have E3H8. Agreed? Yes? They tell me that my E is 91.72%. This is what they gave me. Agreed? And they told me that my H is 8.73%. So therefore, I'm going to assume what? 100 grams. Start with what you know. Can I start stoic with an unknown amount of E? No. But can I start with grams of H? Yes. So I'm going to start out with 8.73 grams of H times 1.008 grams of H and 1 mole of H. Stoic step. For every how many moles of H in the subscripts? For every 8 moles of H, I have 3 moles of E. That's equal to 3.25 moles of E. I know my mass of E, right? So I'm going to take my 91.72 grams of E divided by my 3.25 moles of E, and I got 28.01 grams per mole of E. It's okay, as long as you get the right answer. Yes?
I know we fit one more in here, but it's 173.
Oh, wait, it's silicon. It's silicon, by the way.
Yeah.
173, there's no way I can do that.
Yeah.
But let me just walk you through it. And I did do this second period. All right. Can I throw out my answers from last period really quick?
Yes.
So on 173, this is very similar to what we were doing. All right. But on 173, you have two reactions. Sorry. You have two reactions. Here's reaction one.
I thought it was one reaction.
No, there was two reactions going on here. The CO2 and the H2O. Reaction 2 was the NH3. So I run this to grams of C, this to grams of H, and this to grams of N. But when I'm dividing by my total, these first two have to be divided by reaction 1 total, and this one has to be divided by reaction 2. That's the thing that's tricky about this one. This is a true Chani boy, all right? Because you have carbon, hydrogen, oxygen, and nitrogen. So subtract to get your oxygen, assume 100 grams, get your empirical formula. So the thing you have to know on this one is there's two reactions. So you divide by a different total for these two, both by 0.157, and this one is divided by 0.103. Yes?
At the end, like we got to the whole divided by 1.31.
Okay.
And then we were like, for C, it was 2.3. We were like, do we just take it to 2.5 or 2? So like.
Yeah,
we took it to
that's
2.3,
tricky.
So like,
It's like 2.3-ish, so that's like a multiply by 3.
so you just kind of you have to figure out.
Yeah.
what you
Figure out like what's going to give you closest to a whole number.
should- Okay.
Because that was like, was it exactly 2.3 or what was it?
It was like, when I did it, it was like 2.4 actually. It was like 2.39.
Okay.
So if you just round it up to 2.5 and then multiply everything by 2.
Yeah.
Sorry.
So that's weird. You will know on the test tomorrow. It won't be like
won't be-
borderline. It won't be
You got
borderline.
everything right.
Does that make sense how this is two reactions here? And you got to read it with the book or it doesn't like make a lot of sense. I did work out, trying to see second period. Second period. Oh, actually that was. Second period I worked out, no? That was almost everything. I did 94 second period, if you guys want to see that.
Oh, they're tiny. These are just 94.
Oh, we did?
Yeah, we did.
These are little babies.
Oh, well then, you can watch the video from second period to see me work out 173.